Okay, a little bit different one today. We're going to actually do some metal casting. So we're going to do it inside, which is not ideal, but that's the only way I can stream it. And we're doing really low temp stuff, so stuff you could melt on your stove if you wanted to. I don't know that that'd be a great idea. I'm not going to melt it on my stove, but we're going to print. Oh, actually, I've already printed. We're going to look at some print settings that you might want to include, or at least orientation type stuff. And then we're going to do a little cast here. If everything goes well, we'll see how it comes out. So some things about casting with 3D printing. So right now we're considering just the FDM style of 3D printing, so plastic extrusion. There are a lot of different ways that you can actually use 3D printing in a casting pipeline, whether you're casting metals or if you're doing plastics or whatever. Most of them don't use the printed part as the mold. That's just not possible. The temperatures that are involved, even if you're just doing like a resin casting where you've got two-part resins, you mix them together and pour them in the thing, even those usually get too hot when they're exothermic. So whenever they actually are curing, they get pretty hot, and even those typically get too hot for pouring directly into like a PLA mold. You might be able to get away with some of the higher temperature printable materials, some PEEK or something like that as a mold, but your PLAs and PETGs and things like that, most of them are not going to hold up very long. At least they might hold up once. A PLA may not hold up once. PETG, ABS, ASA, those things they might hold up once, but they're going to get deformed just from the temperatures involved with casting. Now, if you're doing plaster casts, where it's like plaster of Paris, that you probably will be able to do. It does heat up, but not to the same temperature. So if you make your mold thick enough, then it probably will be fine. I haven't actually tried that, but that would probably be okay. What usually happens, though, is the thing you print is used to make a mold. So some other material ends up being the mold, and the thing you print actually ends up being the master. So that's what we're going to do today. Is when we're going to do a really simple. We're not going to do anything complicated. We're going to do an open pour, so there's no like two parts to the mold or anything. There are plenty of channels on YouTube that have all of that kind of stuff on there. If you're interested in that, this is just, hey, I want to make a metal part, and I don't need a lot out of it, but I don't want to also put a lot into it. So that's what this is. Now, let's look at some of the materials you might cast with. First thing you're going to find out is that unless you have some sort of melting furnace, then you've got to stick with the low temp metals. And there are low temp. Let's go over here to Amazon and look at some of them. First of all, there's some casting. So if you're more serious, here's some little electric furnaces. They actually work really well. If you're wanting to cast things in the aluminum, maybe these could probably go up to brass, probably. So you could do that. That's not what we're doing, though. We're doing the low temperature. Now, once you get into the low temperature stuff, most of it that you're going to find is going to have lead in it. And then you have to deal with, it's not a problem, you just have to be more careful. So lead fumes, when you're heating lead, the lead fumes are noxious and dangerous, hazardous fumes. If you're cutting it, like maybe you need to cut this piece into a smaller piece and you get a hacksaw out, hacksaw wouldn't be as bad, but like a grinder wheel or something, and you've got lead dust everywhere. That's bad to inhale. What else? What other parts of lead? So skin exposure. Some people are sensitive to lead. Now, it doesn't like normally absorb into your skin, but repeated exposure could have side effects there. Obviously, if you ingest the stuff, that's generally not good. It's not good. So you do have to be aware. Like I typed in low temperature casting metal lead free. The very first one I get, it contains lead. So you have to make sure what you're actually looking at here. This fishing tackle weight that's bismuth tin, this one is lead free. So there are some low temp, and low temp here means usually around 200 degrees Fahrenheit. This one, well, this one's more. This is 281. The lead, the presence of the lead makes it melt lower temperature. So the really low stuff almost always does have lead in it. We're using a kind of, I guess, not this, well, ours is probably in this range. Ours is more of a lead-free bismuth. This one is also bismuth. I actually bought this one a long time ago, and I don't remember what it is. I just remember it's lead-free. There are some relatively low, so 281 Fahrenheit. That's not too bad to deal with. You can generate that most any way you want to, a hot plate if you wanted to do that. Let's see. A really good one, if you want to look for it, they probably have it here, is Fields metal. Fields, yeah, right here. Costs more, $80 for a little ingot of it. But this is melting at 150, somewhere in there. Well, it's 144, it says in the title, 144 Fahrenheit. So that's a really low temperature. So you can get super low melting temperature that does not have lead. This one's bismuth, tin, and indium. The lead was replaced with indium in this one. So there is this one, Fields metal. There's a Woods metal, a Rose metal, or just search for low temperature, lead-free. Or if you're capable of handling lead, so you've got the facilities for dealing with that, then sure, do what you want to do. But there are ways to get away from lead casting and still be low temperature. We're using something more like a low temp bismuth based thing. I'll show you in a second what we've got over here. So you need that. So you need some kind of metal. You probably don't want to, actually this first one I showed you was fishing weight. So you could technically go find some of the lead free fishing weights and use those. I haven't done that, but you could do that. Or maybe you could make custom fishing weights, because they do have lead-free versions of that you can get pretty easy. Or what I did is I did order it from, I believe I ordered mine from Amazon, but it's been so long ago I don't really remember. It's been years, so I don't know exactly. So you need that. Then what we're going to do is we're going to do a sand cast. So that means that we need some sand. You can't really, I guess you technically could get some like play sand or whatever. The problem with the difference in, I guess not problem, the difference in casting sand and just sand you get out of your yard or Lowe's or someplace like that is that the casting sand is going to have clay in it somehow, so it's going to hold together better. So it's like 90% sand and then 10 or so % clay that's going to hold it all together. And so you either need, it's called green sand normally, although it's not green at all. At least most of the stuff I've seen is not green. Maybe some of it is green. But they usually if we scroll far enough, there'd be some here. I don't see any actually right now. Let's just type in, oh, actually it's right here on the top. So right here, this kind of sand, you would need something like that if you're going to do a sand cast. Otherwise, you won't hold the detail of your part. So there are some processes where you have your part, it's printed, and you encase it in plaster. So not sand, but like plaster of Paris, but it's not the same as plaster. It's a specialized version of that. It's called investment. And what happens in that one is that you encase your printed part in all this plaster, this investment, and then you burn out or melt out the plastic. So normally this is done with wax, so it's called lost wax casting, but you can do it with PLA. You can do a lost PLA casting. And in fact, there are filament-based wax materials specifically for lost wax types of casting. I've never really printed with those. Actually, maybe I have. Maybe I haven't, but maybe some of the students have. Because I do think I bought some a while back. And it works okay. It's not great, but it does work okay. We'll see if we can find some in a minute here and show you what it looks like. Regular blue filament, but it's waxy. So the idea with that process, though, is that you're going to create a cavity wherever your part was. So if you want to go that route, then you're going to have one of these, something like one of these furnaces here. Not one of these are for melting the metal, but something like this where you can get up to a sustained high temperature, because we're going to have to melt out that plastic while also curing the plaster at a set rate. So this process might take 10 hours, right? So it's a long process because you have to slowly ramp up, maintain, and then cool down your mold. Otherwise it'll crack. So that's a lengthy, time-consuming process. But the result of it, I wish I had my little Millennium Falcon here, but I don't have it here. But you can get some really high detail metal prints that way, or metal objects that way. You didn't print them, you printed the master and did all this casting process. We're not going to get that kind of detail. We're not going to have any kind of vacuum pulling our metal into the mold or anything. It's just going to be gravity. So ours is going to be sort of low detail, but I think it'll be good. But you need some kind of casting. I have, what do I have? I have Delft clay, DELFT clay, which is very similar to this stuff right here. This is Petrobond, same stuff, just a different company. So I have that, like a 4 or 5 pound, doesn't say on here. There's a big bag of it. I've had it a long time, and you can reuse it to some degree. The parts that touch the metal sometimes can get burned, and you don't reuse that part, but the rest of it you can reuse. So it lasts a while. So you need that. So you need some kind of sand to cast into, some kind of metal to cast into the sand. You need a master, which you're just going to print. We're just going to use the same PLA we've been using for those calibration tests. We're going to use that PLA. That part doesn't really matter on the composition of the material because it doesn't ever touch the metal. So we're not doing any of those kind of castings. And then you need a way to melt the metal. So these low temp stuff, you can literally melt on a hot plate in a pot, you know. I do have one of these type of things. This one's more fancy than what I have, but mine's similar to this. So it's just a little electric cast iron scoop, basically. So that's what I have. You plug it into the wall. This one actually has an on-off switch. Mine is just you plug it in or you unplug it. So mine's really low end on that. I don't see the one I have. Let's see if I can find it. Let's see. Oh, gotta type. Let's see if any of these. No, these are. Oh no, that's it right there. Although the one I was looking at before was the same price. So this one, this is all there is to it. It's just a little heater, cast iron cup that you can put your metal in, and you plug it in. And that's all it does. And a little stand to set it on, so it doesn't burn whatever you set it down on, because it does get hot. So you have to have some way to melt the metal. And those things, a master, some kind of sand to cast into, some kind of metal to cast, and then some way to melt the metal, that's really all you need to get started. Now you need the safety equipment, like safety. I've got some safety glasses over here. I have some leather gloves, although we're going to be really low temp, so that'll be okay. But I'm gonna still use the leather gloves, and we're gonna cast something. So let's look at what we're gonna do. I found this on Thingiverse, Star Trek: The Next Generation Communicator. So since we're doing an open pour, that means a couple of things. I'm limited on the shape of the object, and this one fit most of those. Now this one doesn't have draft on this edge right here, or this edge. There's no draft on that. Draft is, well, and there's no draft on the edge here either. So this is not ideal for casting like this. But what draft is these sides would be angled. So they would be tapered to where when I put it in the mold and pack the sand all around it, and I go to take this part out and leave the cavity that it makes, there would be an easy release from that. If there are vertical walls, then the sand's going to want to stick to this, and it's going to pull chunks out, and we probably won't get a super clean release from our part. We're going to put some release agent on it, cornstarch, but we're going to put that on there to kind of help pull it out of there without pulling our mold apart. But a better thing would be if this part had draft on it, so it had like 2 or 3 degrees of draft on all these edges, so they weren't vertical straight up and down. We'll be able to create a mold. We might like see how this inner part is tapered in. This is a lot of draft, but this is one of the features of the part actually. That would be draft if it was just a little bit, just 3 degrees or so. This one, you know, like 45 degrees. So vertical edges are not that friendly for sand casting. Overhangs are not possible for an open pour. So if you want overhangs, like it's going to have a part that once I pack sand around it, I can't get my master out of there. I can't pull it out without tearing apart the mold. Then I've got to do a multi-part mold or a 2-part thing. I've got to have cores, all this other. It gets way more complicated. Or I have to do that lost PLA, lost wax type casting where I just encase the whole thing and then burn away the master. This one, the master will be reusable if we wanted to make more of these. If I were going to make these for real, I would create this with more draft on it so that it was easier to remove. Now I have to think about, since it's printed, I'm not going to do any post-processing on this. You know, it's just a demo of kind of how the process works. We're not trying to make fancy stuff. But I would want to clean this part up after it's printed and make it as smooth as possible. Like get rid of the layer lines and all that kind of stuff. We're not going to do any of that. What I did is, instead of printing it flat like this, which would be okay, the downside to printing it flat like this would be, let's slice it real quick and see how the layers are pretty obvious. Yeah, and I'm at 0.2. I can't go much below 0.2 millimeters. Pretty sure I'm on 0.2 millimeter layer height. Yeah, 0.2 millimeter layer height. I can't go much below that with this because I've got the larger diameter nozzle on there, so I'm kind of stuck at 0.2 being about the thinnest layer I can do. And this just wouldn't look that great unless I wanted it to look 3D printed. So instead, what I did to at least kind of get rid of that is I turned it up on its edge. So something like that, and then I think I had it, let's see, it's still on the printer. I had it kind of like that. So I had to have some support in there, but what this will do is now the layers going across here will resolve the detail a lot cleaner. So I did have this support. It does have a hole for a magnet in the back. I'm not really concerned with that part. But now you can see I've got a much smoother surface, and I do have this, you know, kind of stair step on the bottom here, but that's just the way it is. So let's look at what I printed. It's still on the printer. Here's well, it's over here. See if we can pull it forward. Oh, I did get, this is the Chow Think PET bed, so it's got a carbon fiber kind of pattern on it, and it's working really well, just as well as the other PEO bed. I don't remember who made that one, but this one actually fits. I got the 235 by 235, so it actually fits the thing, versus the 225 that I had last time. So here's what I have. Let's see if we can get this off of here. I'll probably move the printer out of the way because we've got a bunch of stuff down here. So there's our thing. Now, a couple of things. Let's see if we can get the support off. I haven't actually. This is the Orca slicer support, which is Prusa slicer support. I haven't tuned it at all, so we might have some issues getting it off of there. Let's see. Yeah, it's actually kind of stuck. A little too much. Let me work on that for a second. So it will come off, but it's the gap between our model and our support's a little too tight, I think. And it's not coming off of there very easily. And that's a thing. I didn't even think about, because my other slicers, their supports have been tuned to where they work a little better. Didn't think about this one having not been tuned. I think we're going to get it off. It's just going to take a little more effort than what I would rather, what I'd want. Might have to go get a pair of pliers to really grab a hold of it. Let's see. All right, let's get this. That actually worked not too bad. I use these. These are welding pliers, but they have big, strong jaws here so that you don't get a lot of deflection when you go and clamp down on this stuff. All right, so a couple of issues that we would need to fix, but we're not going to. So there's some surface problems down here. Whoops. Particularly down here for some reason. Probably because I had it sitting on the bed kind of like that. Oh no, it's more like that. And that just didn't print too well there. So we would need to clean that up. This is pretty jaggedy down here. The top pieces up here are a little melted, so I was not cooling well. So with this printing like this, the last little few layers were just sitting right here on top of this peak up here, and they did not print very well. That's going to be kind of true when you have a small little piece that's at the top of your print. A couple of things you can do to mitigate that are there are some minimum layer time settings that you can try. You know, make sure that it doesn't just sit there on top of the layer, and it slows down to give cooling time, basically. So you can try that. What I usually do that works best, if it's feasible to do, is build in a sacrificial part or a second one. Print two of them. You know, one here and one here, so that the nozzle has to print on this one, then move, print over here while it's over here. This one's cooling. While it's over here, the one in the other part is cooling. So just print two of them. That's one way to get those thin pieces to work. Another thing you can do is make sure your part layer cooling is up to par. Or you can just print a, if you don't want to print two of these, you know, it's too much material, you don't need to, whatever, print another just column somewhere so that the nozzle has to move away from this one, let it cool, go do something else, and then come back and work on this one. Otherwise, you'll get, you know, kind of these edges up here. So what we should do, if we were trying to make these for real, is we should go and clean this thing up, coat it with some heavy build primer, and get it smooth. But we're not doing any of that. So we're just going to go with it like it is. So let's look at what we've got here. I'm going to have to clean out some space because we've got too much stuff in the way. This is if you did want to do a two-part mold. We're not going to do that. Get that out of the way. Here's our sand. So we just got a bag of sand. Here's the piece that I've been chopping off of what we're going to cast. So this is just an ingot, and then I've cut up some pieces there in the little pot over here. Let's get all of our melty stuff out of here. There's a piece of skirt from an old print. Let's get that out of here. I'm just on a metal tray, so steel tray. Have a spoon. We will probably generate a lot of dross on the top of this when this metal is melting, so you scoop that off because you don't want that in your cast. We'll at least do that. Got some safety glasses, some leather gloves. I have this, so some cornstarch. That's going to be our parting agent. So we already know that we're going to have a little bit of an issue getting the sand, getting this to release from the sand after we've molded it. And so we're going to coat this piece with our cornstarch. There are a variety of powders that you can use for your parting. It's like a release agent for your parting agent. As long as it's a fine, so really small particles, dry powder, it doesn't react to heat in some negative way, because it's going to end up in the cavity that's, or at least some of it's going to end up in the cavity that gets the molten metal poured into it, then it should be okay. So cornstarch is fine, and it's easy to get. You don't have to order special stuff. In here, let's get our bag of clay out. We do need some kind of way to hold our sand, and I just printed a while back. I just printed this. So we're going to put a little part there, and we've got a set of walls, and we're going to put our sand in there. So that's what we're going to do. You can, they sell the types of things like this. Oh, I've got dirt everywhere. Not dirt, but casting sand. So there's some down in here. Let's see if I can get it out. But this one, I don't remember. I might have downloaded this, or I might have made this. I don't remember if this is how official this one is. I think it's just something I made. It looks like I printed it in PETG just to have a little bit better temperature, although this part is not going to get hot at all. This part won't even be part of what we're casting. This will hold the sand, and you can see apparently I touched it right here because it's kind of melted. So let's see if we can start this little process. Oh, and our melting. So over here, let's move some stuff away. So over here, we've just got our little pot, and there's some leftovers from, this is not on right now, and then an old cast that I did, or a piece of a cast, or a new piece. That's we might be able to just melt this part. I don't know. We've got all of this, so we'll get this started. And by started, it just means for this one, you just plug it in. It would be nice if this one, or if I had one of these that had a switch on it, that you could just turn the switch on and off. But this one, it's just you plug it in or not. All right. So over here, we're going to put some of our cornstarch parting. That's a lot. Kind of get it around. You would probably glue this down, just a little dab of super glue so it doesn't slide around on us. But again, we're not being super worried about what we actually get here. I don't want the cornstarch to really build up in the details, though I do want to get as many details as I can. All right, something like that. Okay, get that out of the way. Now let's put our little walls on here, and we're going to add sand, or well, not sand, our green sand into here. Now, the green sand is going to be kind of lumpy, so you do have to loosen it up a little bit before, so it's more sand-like. And I have not done that, so ours might be a little bit compacted together because I haven't cast anything with it for a while. But we'll see if we can get it to go down in here well enough. You might even want to sift it to get, like I see there's a, well, it's off on this edge, but there was a, I don't know, piece of trash in there of some sort. So I'm gonna tamp it down with our very sophisticated tool here. Let's see if we can get some more in there. You want it We're gonna have to flip this over, so I need to fill it all the way up. Get some more. Can't forget you're melting your metal over here. I don't really remember how long this particular one takes to melt, but it's not terribly long. And it's one of those things that sort of like solder, because a lot of this is very similar to solder, where once it melts completely. It's not a very slow process once it starts. Can't remember the word for that. There's a particular word. I think it starts with an E. So the better you do at getting your casting sand in the mold and all around the part that you want to recreate, the better your chances of it coming out nice are going to be. You only get one shot per cast, you know. Once we've poured metal into this one, then we'll have to recreate it. Now we won't lose our master though. It'll still be usable unless we do something crazy to break it, which I don't anticipate. So you can reuse most all of the sand and your master and make another copy. You just have to restart this process of packing your mold. See if we can get the bottom level here. Alright, so we could go on with that part. I don't want to belabor the point. I think our metal is actually getting close. Okay, so now let's see if we can get our part out of there. So there it is. I did remember one part just now. So getting this out is a lot easier if we had put in some kind of thing to grab, like a place where you could screw in a screw or something like that and get a little handle. I'm going to tap it a little bit to see if I can break it loose. These little pieces right here are going to have trouble. Alright, I saw it pop loose. Now, I don't know. We're going to have to sacrifice a piece of it, I'm afraid, to get it to come out of there. Because you want to lift it straight up. And I don't have anything to grab a hold of. So I think we're gonna sacrifice this little edge right here. Or maybe one of these. Okay. Let's see if I can. Oh, there goes our metal. See, it's just all at once, it just melts. Alright, so see how we have some tear out here. We can do some to try and... Oh, I should have mentioned, I do have a fan that's like blowing this way, so that any fumes that do come off of this end up over there instead of towards me. Okay. So, let's get prepared here. Let's move this stuff out of the way. Let's move this out of the way. Move this out of the way. And over here, got that little piece that's stuck on our pour spout. I don't really know what's got it hung up there. So, see the skin on top of this? That's usually not what you want in your dross. I mean, that is the dross. You usually don't want it in your cast. So we'll try and get some of that off of there. I'm going to get my leather gloves on here just to have a little... I mean, this is not at all hot except for the actual heating area. But we'll just try and get some of that off the top if I can. Just to make our part as good as it can be. Alright, so we're just going to pour into here. And now it's going to wet, whoops, a lot now, where it's going to have a lot of surface tension. So let me unplug this. Okay, so that'll cool down. And it's the same when it cools down. It kind of all goes at once. But you can definitely tell, you can even tell from your camera view there that it has a lot of surface tension. So that's why the single-sided stuff, normally what you have to do is you have to go file the back of it off or whatever. And again, if you have a lead-based one, that's one of the parts where all that filing and sanding and everything can create lead dust, or at least dust that contains lead. And that's generally not good. So the stuff that is lead free is a little better on that. Oh, it's still liquidy. While it's cooling, I'm going to take this and move it somewhere not where somewhere where I will be less likely to just accidentally bump it. That part's hot. Let me get it out of the way too. Okay. Oh, it's starting to cool. Let's see. All right, so it's still hot, but now it's cool. It's solid. Not that doesn't make sense. It's still hot, but it's cool. So then you just kind of, oh well, that's removing it. And you know, it actually didn't do too bad. Cleaning up some of this. Let's get you closer to it. It's too hot for me to touch. But let's get, well, there's what's left of the mold. We'd have to repack. You know, it's torn up our mold, but just this part right here that's touched the hot metal, that's probably not worth saving. So you scoop that out and throw that away. It gets kind of crusty, so you don't want to really use that part again. At least I don't want to. So I'm going to get that part out, and then the rest of it we could use again if we wanted to, but we'd have to repack. So there's that sand. Put this out of the way. And then let's get you over here. I mean, you can tell what it is. You can see some layer lines in it, but we didn't do anything to clean up the layer line. We didn't even touch it with sandpaper. We took it straight off the printer, pulled the supports off, and put it in the sand. And we would have to cut away this extra, you know, the overflow. Not a horrible thing to do. A little filing. Usually these low temp stuff are really soft metals too, so they're relatively easy to clean up. It did pick up here, that little corner where our master, where'd it go? So where our master had a bad corner right there, it picked that up in the cast also, but it did pick up the corner, and I think there's enough metal there that you could probably do a decent job of cleaning it up and, you know, filing it to make it look pretty good. I might actually try cleaning this one and once it cools down and see what we end up with. But it looks generally pretty nice. It's definitely thicker than our master. I can't really show you that. It's thicker because of how much surface tension it bubbled over the top of our mold that we made. So if we want it to be the same thickness as this guy, then we're going to have to do a lot of filing on the back side of it, which is doable. But it's probably slightly, it actually is hard to tell, but normally you get a little bit of shrinkage from the cooling of the metal. And so this part ends up some, 5% smaller. I can't really tell, and it's too hot for me to, try and measure anything right now. Maybe next time, Wednesday, I'll come in. This will be cooled up, and I have cleaned it up to where we can compare the two. But it's really pretty simple. You just need some low temp metal. You need some green sand, something that you can make your own green sand if you can find the clay to add in to it. Or there's a Petrobond type that I think you can add an oil of some sort to it. I haven't ever made mine. I've just always bought it. It was easy enough to buy it. So you need that. And the better stuff you get, the more detail you'll be able to pick up off of your print. And then you need a way to melt the metal. I just have that little hot pot, but if you have a hot plate and any kind of steel container, that one's cast iron. I guess you could use a tiny little cast iron pot if you wanted, or a cast iron skillet almost if you wanted to. But the lower temperature ones, even the ones without lead, can melt 150, 200 degrees Fahrenheit, depending on what it is. There are some, you do have to be careful. There are some low temp where low temperature is 400 degrees Fahrenheit. And so you're going to have a harder time melting those things. So you do have to be careful and read the actual melting point of it. Probably the easiest one to deal with is the Fields metal. It just costs more. So it's lead free, super low temperature melting point, but it just costs more. Some of these bismuth ones are not terribly bad, but then the lead free fishing weight stuff is pretty cheap. All right, so that's a little bit different. It does involve 3D printing. It's not directly related to 3D printing, I guess. But if you're ever interested in, well, how can I get metal stuff? This is one way you can get metal things. There are other ways. There are ways you can print metal. We have I think I never can remember the name of the company, Virtual Foundry or something like that. Let me see if I can find it. Oh, I think it is the Virtual Foundry. It's loading. So these are 3D printing, FDM 3D printing materials that are very high content metal. So we have some of it at school. We have not printed successfully. The problem we're having with it is actually heat creep. So normally your hot end has a hot side and a cold side. The cold side is kept cold by the heat sink and the fan that blows across the heat sink. The problem with this stuff is that the stuff itself, so the filament itself, has such a high, like 80% metal or some very high metal content, and it is conducting heat through the filament, and so we're getting heat creep clogs. So we haven't gotten a good print of it yet. We basically have this kit over here, but the idea is that you print your part like this. It can work. We just haven't gotten it tuned on the right printer to do it. And they're using, they have looks like something similar to a Creality, what's that, 5? Something, that style of printer. And then you have to burn out the rest of that plastic so that it becomes metal. So it does shrink. It shrinks 20-something%. And then you end up with a solid metal part that you FDM printed. You just had to process it in between the solid metal and the printed part. And assuming you can do that, then you can make solid metal printed parts that take advantage of the ability to 3D print. So now you do have these really complex geometries. You're not limited to what we just did, where it's, you know, one-sided pour kind of thing. So this is a way, and it's I don't remember what was the cost of these things, $200, $300. I don't remember. The filament's really expensive. The kit, the starter kit's not terrible, but it's not cheap either. It's not something you'd want to just play around with. You'd want to, oh yeah, well, that's the printer, and that's their burnout chamber, or sintering chamber, I guess is more what it really is. But see, these percentages here, that's how much metal is in the filament. So, you know, they're 80, some of them are lower, but a lot of them are 80+% metal and just 20 to 10% plastic that gets printed. So they're difficult to print, but there is a way, even with FDM printing, to print metal parts. And then there's a company, I can't remember which company. It might be one of the Mark Forged products that you can, does a similar thing, but it's all contained in their system of equipment. So that is another way you can get metal from 3D printing. Obviously, there's direct metal printing, you know, laser sintering type stuff. Those are way out of the price range of most every person, and even a lot of industry. They're just very expensive to operate and maintain, and expensive to get started with. So those are usually not, if that's something you need though, there are companies, I'll put out one of them, Xometry, where they have services like like an Amazon, except you send them your STL file or step file or solid part file, you know, whatever file, you send it to them, and they will have all sorts of ways that they can print it. So they have selective laser sintering right there. So that would be, there's metal 3D printing. So they have ways. Selective laser sintering is probably for nylon, but here's a metal printing. So if you need a metal part printed, then this is probably the best way. It's still going to be expensive, like $200 plus per part, but it will be much cheaper than trying to fiddle around with the virtual foundry type of thing, unless you've done that before, and unless you happen to have access to a metal 3D printer yourself. It's probably the best way to go. And this Xometry is not the only one. It's just the first one I thought of. There are several of these online, big, large-scale, not manufacturers, but part makers. So you send them your files, and they will make some number of your parts. It's usually for smaller scale, 1s to 10s of parts, but I assume they could do more than that if you wanted to. So I think that's probably all we'll do today. There's not a lot more, unless you wanted to watch me file this thing. It's probably, yeah, it's cool now. So there's our part. You can see how it's, you know, it's much thicker than what we originally asked for because of the surface tension from casting this stuff. I probably could have done better with getting the right amount of metal in there. One thing about having extra metal, though, is that the weight of the metal forces the stuff underneath it into the mold better, so you get a little bit better surface detail. Looks like I've got, that's probably, that little bulge right there is probably from where I tried to get this thing out of the sand to begin with. Didn't get too much right there. It's kind of underfilled there. And then this looks like a mistake, but it's actually part of the model, the way the model printed. Not part of the model, the CAD model, but part of the printed model. Those are all blurry. I need to hold them further down like that. All right. So that's a thing if you're interested in. It's not insurmountable to get into, but there are some safety things you have to be aware of. Probably don't want to deal with the lead containing materials, and you do have to deal with the heat involved, so it does get hot, so you have to have a way to deal with that. All right, Wednesday we'll be back Probably looking at the Rook 2020, I think, is probably what we'll do Wednesday. But not 100% sure. We're getting close to the end of the quarter, so there's not too many things left.